Excellent. Well, again, thank you for the invitation. I'm going to talk about, relatively technical constraints as we had discussed before the beginning of this conversation. The place where I have been working on the identification is for multi-center clinical trials where the use of software to do the identification does not require or should not require much training because it is being used by trial coordinators across thousands of investigator sites. To give you a sense, at any point in time, like right now, I was just checking, we have about 13,000 active sites with 29,000 users across the globe who are taking images for different types of clinical trials and having to de-identify them. Any one of them is de-identifying, one or two or three. None of them is de-identifying 100, but all of them have to be done correctly per their, GDPR, HIPAA, etc., whatever the regulations are globally. So regulations are very important. The tools that we have provided, we initially developed them around 13 years ago, and they do exactly what you would imagine: delineate a PHI area by region and apply the removal of the pixels across multiple images. Now, you want to facilitate this process because trial coordinators around the world do not have time. Let's remember that they do not have subjects, they have patients. And working towards providing data in clinical trials is not their main objective every day. So if the series in an ultrasound, for example, are misaligned, you cannot simply automatically apply that across all of them. We work on any kind of modality, CT, MR, DEXA, nuclear medicine, as well as multiframes, right? Ultrasound, IVUS, angio, etc. And when you are trying to de-identify these pixels, and I'm exclusively talking about pixel de-identification here, one of the big constraints that we have is that all of these operations need to occur on the site side before crossing that firewall without having to install absolutely any software on that trial coordinator's computer, because typically around the world, trial coordinators are in PCs inside the hospitals and they are not able to, in fact, install any software. So everything has to run without any .exe being installed there, which can be challenging, to say the least. Initially, many years ago, we were doing this through Java Web Start. Now it is all done in the browser, and browsers have their limitations as well. Now there are issues around compressed images to be able to do this on a browser. Many of these images, particularly when you have things like ultrasounds and angios, are compressed, and you need to decompress in order to de-identify. Now, David Clooney has done some really good work on the ability to redact compressed images by showing the user the decompressed image and then blasting the corrected pixels in the compressed ones. But being able to implement this in a browser, think JavaScript, is very challenging because you have limitations in memory. You have all sorts of different limitations as well. So one way that we are beginning to approach this is to define modality formatting. So, take different vendors, GE, Philips, Siemens. Where are they typically burning PHI on the images? It is annoying, as one of the previous speakers said, that they are still doing this, but they are still doing it. And then based on region, de-identify those pixels. The other that we are looking at and have done some testing is using AWS recognition, which is really very good at finding things that are written text, so to speak, but would need a trained system to remove the PHI. And as many of the speakers have spoken before, these systems are mostly here, and if not, almost here. But there is this big problem that using something like recognition, using something like ChatGPT today, or the equivalent future of those, BARD, etc., those run in the cloud, and you fall into the problem of you cannot send images to be de-identified in the cloud before you de-identify them locally, and that becomes a circular argument that is very, very hard to deal with. We are looking into, doing constrained embeddings in local machines that can be run on JavaScript to be able to do that locally. And which brings us to the use of AI and LLMs for this. Now, the question is, how will these AI solutions work? And are we talking about computer-assisted de-identification? And again, please keep in mind that the type of users that we have focused on for the last decade plus are individuals who need to send these images to imaging core labs of different kinds, whether academic or otherwise. Now, with decentralized clinical trials, you're getting more people that have less experience in doing this. So this has to be very, very easy to do. And so is it computer assisted or autonomous? Today, I don't believe that autonomous will be here, as many of the speakers have said, for a little while. And then, what is the scalability and adaptability of these solutions to handle very large data sets? Where will it run is a very big question. And the other one is time. Anything that takes more than a minute, as far as the user is concerned, is infinite time. So where are we going to do this? Those are some of the technical challenges we are seeing coming to the future, but a great opportunity as well. So there are a few other things having to do with regulation that I think we're going to talk about in a little bit, but I wanted to stop here, be conscientious of time, and appreciate the opportunity, and happy to answer questions both in the chat and afterwards when the questions will come up. Thank you very much.
Thank you, Abraham. Much appreciated.